Hello, and welcome to a little video about the Unit 3 test review. Let's get started. The first thing that we're going to do is write some equations for linear functions in slope-intercept form. Now, in order to do this, from a graph, we just need to look at 2 points. The first point that we want to make sure to look at is the y-intercept. Here's the y-intercept. B is our y-intercept. The other thing we need to do is count the slope. We do that going left to right, and I personally like to start on the y-intercept and then go to the right. In this case, it looks like we're going to go up. All right, let's do it. 1, 2, 3, so I went up 3 and to the right 1. So here's my function. F of x equals, was this the color I used? Yeah, 3 over 1 x. And then since our y-intercept was -5, I write -5. Let's try that again. All right, here's my y-intercept. It's a +5. Now let's count our slope. To go from left to right here, it looks like I'm going down. I'm going down 1, 2, and to the right 3. So here's my function. F of x equals, since I went down to 2, it's -2 over 3, put an x. And since the y-intercept was 5, plus 5. Whenever we have a positive y-intercept, you want to make sure to write a plus. The most common mistake I see with this is forgetting, I was going to just erase the plus sign and show you how silly it looks. People writing this. You got to make sure to put that plus sign in there. All right, this one here, oh wow, it has 4 points, but you know what? It doesn't matter. All I need is 2. I'm going to use this y-intercept, and then I'm just going to go to the right. Looks like I'm going up 1, 2 spots, and to the right 1 spot. So f of x equals 2 over 1 x. The y-intercept is +3, so +3. Last one, okay, there's 2 points, perfect. Here is my y-intercept, and it looks like if I'm going left to right, I'll need to go down. I'm going down 1, 2 spaces, to the right 1 space. So, f of x equals -2, since I went down, over 1 x, and then +3 because our y-intercept is +3. Wonderful! So that is how we find slope-intercept form from graphs. Now let's do it from tables. Here is a table for number 2. The first thing we're going to do is determine the average rate of change, which is our slope for the problem. Okay, so we have the slope formula. I'm going to write it down right here. Oh, what's going on? I want to write, there we go. M equals y2 minus y1, x2 minus x1. Let's label our table with x's and y's. And then I'm going to color code it as well. M equals. Okay. This column right here is our x's. So I'm going to make this x1, x2. Oh, I don't want to do it all the same color. Let's fix that. x2. Better. So that means this is our y column, y1, y2. Okay, let's follow the formula. y2 is 9 minus y1, which is 6. On the bottom, x2 is 2 minus x1, which is 0. 9 minus 6 is 3. 2 minus 0 is 2. Can we reduce 3 over 2? We cannot. If you're ever unsure if you can reduce a fraction, just put it into our fancy calculator. If you put 3 over 2 as a fraction and click enter, you'll either get 3 over 2 back, because that's as reduced as it goes, or if possible, it will give you the reduced fraction. Letter B asks us to write a function to model the table of values f of x equals, we want to write the actual function. Well, we have m already, so we can start with that. F of x equals 3 over 2x. Right, this is m. Now we need to find b. B is our y-intercept. Whenever we have b, we're looking for a point on our table that's 0, comma b. So 0, comma a number. So we're looking for wherever x is 0. Let's find it. Here it is. Here x is 0, so the y-intercept is 6. Since it's positive 6 plus 6, determine the value of the function after a constant rate of 12. What that is asking us to do is to plug 12 into our function. We can only plug in numbers into letters. We cannot plug numbers into numbers. That's why when I wrote this function, I replaced the x's with 12s. Oh, let's highlight this 12. Now, what you can do next is put this whole part into your calculator and click enter to get your answer. Well, I'm just going to talk through it. 3 halves times 12 is 18. 18 plus 6 is 24. Right? Yes. Let's do this one more time. Here's another table. Beautiful. Make sure we can still see the slope formula. There it is. Let's label. x1, x2, y1, y2. Whenever we have g of x or f of x, that's our y's. All right, let's find slope. y2 is 15 minus y1, which is 19. x2 is negative 2 minus x1, which is negative 4. On top, 15 minus 19 is negative 4. On the bottom, negative 2 minus negative 4 is positive 2. Can we reduce negative 4 over 2? If you put it into your calculator, you would get negative 2. So yes, we could. All right. In letter B, we're going to write the function. We already have m. Fantastic. F of x equals negative 2x. Now we need to find b. Remember, b is our y-intercept. The y-intercept happens when x is 0. Look at your table. Do you see where x is 0? What's the y that goes with it? 11, yes. At least I hope that's what you were thinking. Boom. Plus 11. In letter C, we're going to determine the value of the function after a constant rate of 5. Just like before, the only place that we can plug 5 into is x. So f of 5 equals negative 2 times 5 plus 11. You can plug this part into your calculator. I'm just going to talk through it. Negative 2 times 5 is negative 10 plus 11 is 1. Fantastic. Think we got 2 more to practice? Beautiful. All right, I'm going to rewrite the formula for slope here just so we have it in front of us. Okay, let's determine the slope. M equals x1, x2, y1, y2. All right, on top we got negative 3 minus negative 8. On the bottom I have positive 3 minus 0. Negative 3 minus negative 8 is 5. 3 minus 0 is 3. Can we reduce 5 over 3? If you're not sure, put it into your calculator and click enter. See what happens. Turns out 5 over 3 is as reduced as it gets. So we have our slope. Let's start writing our model. F of x equals 5 over 3x. Now I gotta find b. Remember, b is our y-intercept. The y-intercept happens when x is 0. Do you see where x is 0? Yeah, right here. So, minus 8. Now, if you had written plus -8, you're still right. Letter C is asking us to determine the value of the function after a constant rate of 15. So we're going to take 15 and plug it into x because the only place that we could plug in anything in an equation is in the variables, the letters. We cannot just replace numbers. Okay. As always, you can plug this part into your computer and I'll talk you through it. 5/3 times 3 is 25. 25 minus 8 is 17. One more of these, and hopefully you'll feel confident for the test. All right, let's label our table so we could find the average rate of change. x1, x2, y1, y2. All right, I'm following that formula on the left-hand side for slope. y2 is 3 minus y1, which is 10. On the bottom, I have x2, which is -1, minus x1, which is -2. Okay, 3 minus 10 is -7. -1 minus -2 is 1. -7 over 1, does that reduce into anything? Kind of. You can rewrite it as just -7 if you'd like. All right, we got part of our model ready, our function. -7x, because we know our slope. Now I need to find the y-intercept. The y-intercept happens when x is 0. Look at your table. Can you see where x is 0? At -4. Perfect. -4. Now we're going to determine the value of the function after a constant rate of 6. Oh, I didn't mean to select everything. Stop it. No. No. Okay, there we go. Remember, we can only plug 6 into x because we can only replace variables, our letters. We cannot replace numbers. As I did for the previous couple problems, you are welcome to just plug this into your calculator. All right, -7 times 6 is -42, minus 4 is -46. All righty. Number 3. A cactus is currently 4 inches tall and grows 3 inches per year. Let's write the situation in function notation. Now for function notation, what we need is our slope or our rate of change and our b. That's our y-intercept, but that's our beginning. So let's decide, what is our change? Is the cactus currently being 4 inches tall or growing 3 inches? Which one is the change? It's the 3 inches. It's the word growing. This is our m, our rate of change. So 3x plus 4, because 4 is our b, beginning. How tall will the tree be in 12 years? Well, let's plug 12 into x. right. 3 times 12 is 36, plus 4 is 40 inches. Don't forget units. We're talking about a cactus. Number 4, a sunflower is currently 23 inches long and grows 8 inches per year. Let's write a function. Once again, think to yourself, what is the change that's happening? Is it the sunflower being 23 inches long right now, or the fact that it's growing 8 inches per year? It's the growing. Growing 8 inches is our M. That's our rate of change. So 8x. And then our beginning is 23 inches. How tall will the sunflower be in 12 years? Well, in order to find that out, we're going to plug 12 into x, because that's the only thing we can replace. And if you think about it, it wouldn't make sense if we replaced 8. 8 is how much it's changing. It's currently 23. You can't replace that. We can only replace x, which is the years. All right, you can plug this into your calculator if you'd like, or you could just do it by hand. I'll talk you through it. 8 times 12 is 96, and 96 plus 23 is 119. Oh, inches. It'll be a very tall sunflower. I love sunflower seeds. They're so good. Ooh, 3B, here come our transformations. All right, for questions 4 through 7, oh, I made a typo. It's 5 through 8, boo. That's okay, I'll change it for next year. Anyways, what we're going to do is we're going to graph the original and the transformation. Let's start with the original, number 5. We got 2x plus 1, reminding you that whole numbers are technically all over 1. Okay, so my y-intercept is 1, so I'm going to put a dot there. The slope is 2, so I'm going to go up 2 spots, to the right 1 spot. Now, you would be ready to use your straight edge at this point. I don't have a nice straight edge to use on OneNote, and the tools that make arrows drive me a little crazy. And I don't need to be crazier than I am. So I'm going to do it the old-fashioned way by just adding more dots and trying my best. Trying my best. There we go. To connect them. All right. The transformation that I have is -1 times f of x. This is a dilation. So we're going to do this. We're going to do, we're going to unselect that. We're going to do -1 times 2x plus 1. Because we're multiplying by f of x. Let's distribute. -1 times 2x gives us -2x. -1 times +1 gives us -1. Okay, let's graph this. Just like before, remember that -2x is actually -2 over 1x. I'm going to graph this graph in a different color. Let's do this one. All right, I'm going to start at -1. My slope is -2, so I'm going to go down 2 to the right 1. That's all you need to draw your graph, so make sure to grab a straight edge and draw one. I'm just going to follow the old-fashioned way. Always happy to show you this way if you are curious. But, you know, we're good following the laws of geometry and using 2 points to draw a line. Fantastic! There we go. We graphed the original and the transformation. Number 6. F of x equals x plus 5. Oh, all right. So, do you know what number is actually in front of x that we don't see? It's 1. It's that invisible 1. So, 1x is actually 1 over 1x. All right, let's graph it. We start at 5, and then we go up 1, right 1. I'm going to keep making dots. You know how it is? There we go. Ding, 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 ding. Perfect. Now our transformation says f of x minus 4. Well, okay. We're going to take f of x and subtract 4 from it. So we have x plus 5 minus 4. 5 minus 4 is 1. So our function is actually x plus 1. And just like before, this is a 1 over 1. I'm going to draw it in this color now. All right, this one starts at positive 1, and then we go up 1 to the right 1. Yeah, we almost went too far down. Okay, we're just going to pretend this is way straighter than it looks. I bet yours looks beautiful because you're using a straight edge, right? You're using a straight edge? You better be using a straight edge. All right, number 7. Okay, let's graph the original. It starts at -3. I know fractions look crazy and most people hate them. I personally love them, but I'm a math nerd, so that's an exception. But specifically for slope, I prefer fractions. I think they're more obvious. They tell us exactly how many up or down and how many to the right. Well, in number 7, it has -2 over 3, which means we're going down 2 spots, to the right 3 spots. That's all you need to draw your line. I'm going to keep going down 2 to the right 3. And then I'm going to also go backwards. Again, if you want me to show you how, I'm happy to show you how. But all you really need is 2 dots and a straight edge. Next, we're going to perform another dilation where we're going to multiply f of x. Let's do it. -2 times -2/3 x minus 3. All right, I'm running out of room here. I'll fit it in somehow. Okay, so -2 times -2/3. First of all, it becomes positive, and it becomes 4/3 x. -2 times -3 is positive 6. All right, let's do it. Let's graph it. We're going to start at 6, and then our slope is 4 over 3, so we're going to go up 4 to the right 3. That's all you need. Go ahead and graph your line. I'm going to go backwards a little bit to make it a little nicer for mine. Now that's as good as I can get it. Beautiful. All right, last one. The transformation is adding, so it looks like we're going to be going up. First, let's graph the original equation. This one starts at -5. Our slope is 1/5, so I'm going up 1 to the right 5. You only need those first 2 points, of course. But I just wanted to draw myself a couple more. To attempt a straight line, we tried. We did try. Okay, now let's do the transformation. Let's add 7. So we're going to have 1/5 x minus 5 plus 7. -5 plus 7 is 2. So 1/5 x plus 2. Let's graph it. I'm going to start by putting a dot on 2, and then going up 1 to the right 5, up 1 to the right 5. And of course, I'm going to go backwards. Beautiful. Here we are. So as you can tell from the graphs, the 2 problems where we multiplied, our lines crossed. The 2 that we didn't, they ended up being parallel. All right, I think that's it for the review, right? Fantastic! If you have any questions, please ask me or whoever else is helping you study. Otherwise, good luck on your test and have a wonderful rest of whatever day it is for you today. Bye!